Welcome to the January Forum of Calumet Revisited for 2026. I am Michael Bowes of the Association for the Wolf Lake Initiative. Valerie Penninan, Professor Emerita of History at Calumet College of St. Joseph, is co-sponsor. Before we introduce tonight's speaker, are there any announcements? If not, um, tonight's speaker is Dr. Phil Willink, a researcher and co-author of Fishes of the Chicago Region. His talk will be followed by a Q&A session. Phil?
All right, let's see if I can share my screen. I know I'm going to pretend I'm talking about computer stuff and watch me crash the computer and Zoom here. All right, there we go. Let's see here. All right, does that look good to people?
Yeah.
Yeah,
All
I
right,
see it.
okay, good. I mean, it looks good on my screen, but you never know. All right, so first off, you're probably wondering about the image, the background image here. Basically, I asked AI to give me a image depicting the capabilities of AI. And this is what it gave me. It also gave me like a half page description of what it was thinking. As to whether it was really thinking or not, it's another issue. But anyways, it did describe what all of the symbolism here means. I forget what all that is. I have it somewhere. But I find this rather fascinating, this picture with all the symbolism on here and everything else associated with it. Um, So I'm going to talk about the role of artificial intelligence in conservation. There is one disclaimer I'm going to make about this. Many of you know me. I'm a biologist. I'm a researcher. I attempt conservation as best I can. I am not a computer scientist, so I am coming at this from a very similar perspective as many of you, I suspect. So I'm not coming at this from the world of computer science, although I have done some programming. I'm coming at this, you know, of what use is artificial intelligence to what we are doing. And I'm sure you've heard about artificial intelligence. It's in the news all the time, especially, recently over the past year, 2, 3 years, whatever. What's interesting is this topic has actually been around for decades. For example, if let's see here, why is that? There we go. Go back to 1984. Someone named William Gibson wrote a science fiction novel called Neuromancer. And one of the primary characters, if you will, in this novel is actually artificial intelligence. This is way back in 1984. Skip forward a few years, 1989. Let's see if I can move this. There we go. Oh, a little bit. Skip forward to 1989, another science fiction novel by Dan Simmons called Hyperion. There's actually two of them here. Once again, one of the primary plot drivers or characters, if you will, is once again artificial intelligence. Now we can even go back in time, a couple of decades, to the novel Dune. This is published in 1965. And although Frank Herbert doesn't actually use the term artificial intelligence, he refers to thinking machines, and it is an essential part of the world building within the sort of Dune universe, if you will. If you go and look up top 10 science fiction novels of all time, different lists will be a little bit different, but oftentimes these three novels are on there. So artificial intelligence has actually had, quite an influence on the science fiction genre. And it's not just novels. Once again, sticking with the 60s, the novel and movie 2001: A Space Odyssey came out in 1968. And one of the primary components of the plot is the computer called HAL that is basically an AI that goes rogue. Skip forward. Here we go. Terminator. Totally different type of movie than 2001. But here again, a lot of people are fixated on the Schwarzenegger character, which does have AI in it. But actually, the whole reason for the way the world is and the behind the scenes plot is something called Skynet, which is an artificial intelligence. Um, in both of these two movies, and oftentimes in novels, artificial intelligence is sort of the villain in it, but that's not always the case. Go forward a little bit, and there's a TV show called Star Trek: The Next Generation. There's a character in there called Data, and he's an android with artificial intelligence. And there's a lot of episodes in there where they're exploring the issues of whether androids are sentient or not. Are computers self-aware? Are they able to experience real emotions? All that sort of thing. So a lot of these themes that were described or at least explored in this TV series. And then skip forward a little bit more. Here's another movie, Ex Machina, that came out in 2014. This is sort of, at least in my opinion, a bit of a disturbing, freaky movie. Once again, we're kind of going back into the horror genre. Um, you're probably sitting here thinking, oh, but what about this movie, this novel? Yeah, there's hundreds of examples. We could spend hours going through all of this and the influence artificial intelligence has had on literature and the movies. But so this is just, just a taste of what's out there. Um, Couple of other important points I just noticed earlier today as I was looking through this. Back in the 60s and earlier, whenever AI was in a movie, it was usually AI in a computer or maybe a big clunky robot type thing. But over time, it became more and more human, so that today, whenever you see AI, it's basically indistinguishable from people. You can't really tell, at least superficially. So there's kind of an interesting change in themes over time with that about how we're perceiving AI, and I'd be curious to see how that plays forward as we go in the future. Another important point is that science fiction authors and movies, they were not making this up on their own. They were getting this from somewhere, and where they're getting it from is the field of computer science. Because artificial intelligence has been around, believe it or not, since the 1950s. In other words, we've had artificial intelligence for almost as long as we've had computers. So, what I'm going to do now is kind of go through a bit of an overview of what artificial intelligence is. This is going to be a very simplistic explanation. If you want more information about this, there's a lot of YouTube videos. Go read books, find a good computer scientist. It's a huge field. And since it's been going on for over half a century, as you can imagine, there's a lot of details associated with this. So, but I'm going to keep it kind of simple so that we're all sort of on the same page as to what AI actually is. And what it is, in a very basic sense, is a computer program or algorithm. You can give it an input and it goes through the computations. You get an output, and it is then able to be recursive. That is, it can go back to the beginning, and it can also learn based on its output as to whether the output is accurate, inaccurate, close, that sort of thing. And it kind of depends on the context. But it's this learning. It's able to go back and learn or teach itself to solve particular problems. As to whether it's truly understanding, that's a whole nother issue. That's kind of a loaded topic. But that's kind of the basis of what AI is. Um, for many years, computer scientists were working with AI, but there weren't major advances. So, we didn't really hear about it much. We just sort of knew it was there, but there was really limited practical applications for it. And that was until maybe 3 decades ago, 3 decades ago, along came something called machine learning. And machine learning, in essence, is pattern recognition, usually based on a lot of training data. So a very simplistic example here is we would give a computer program or algorithm the pattern 1, 2, 3, at which point that algorithm would then predict that the next number would be 4. All right. So these machine learnings, they're very good at picking up these types of patterns. And they could pick up on patterns far more complex than what I was talking about right there. And the more data you gave the machine learning, the more it could learn, the better it was at it. And so it could recognize more and more complex patterns. And as I said, you could make a prediction. So you say 1, 2, 3, the computer would then say, oh, the next one's 4. Now, another aspect of this is you could give the pattern 1, 2, 3, 6 to the computer. It would then say, this does not fit the pattern. So it could make predictions based on the pattern, but it could also recognize when it doesn't fit the pattern. And the key point here is pattern recognition. This is really the backbone of artificial intelligence, even up till today. It's all about pattern recognition. And the more data you have that you train on, the better that algorithm is at recognizing this pattern. Now, this is all interesting. They had a lot of research applications, but to most people, not particularly useful. But so the next big step was something called deep learning. And machine learning, deep learning, these are closely connected. Deep learning is, in a semi-technical definition, is using multiple layers of neural networks. And a neural network is basically an interconnected number of units or nodes. Okay, so I'll explain this in a little bit more, but it's at this point that computer scientists actually started to model these computer algorithms on the human brain, looking at neurons in the human brain and trying to figure out how the brain works, and then trying to simulate that in computers. So an example here of deep learning of an algorithm kind of using this is, let's say we have a picture of a cat and we want the computer to be able to recognize what a cat is. So you give this picture to the computer. The computer can then break the cat up into different parameters. And each parameter, let's say, is a node. So for example, one node or parameter would be ears, another could be whiskers, another could be tail, another could be fur. And you can go on and on, have more and more of these parameters. So the computer program would break that all up into a network, and then it would have, or one particular layer, but then there would be another layer that would also analyze the same data, but it would refine it, and then another layer refine it, and they could go through multiple layers, refine it, and then the output, initially you tell it this picture is a cat. Now you do this again with another picture, you give it thousands and thousands of pictures of cats, and pretty soon the computer is able to recognize a cat, at least fairly accurately. Then the next step is you give the same algorithm a picture of a dog, and it does the same thing. You tell it it's a dog, give it thousands and thousands of pictures of dogs, and then pretty soon it knows at least what a picture of a dog should be. At least it's going to be pretty close to that. At which point you could then go out on a walk in your neighborhood. You would see someone's pet. You could take a picture of that, send this picture to this computer or wherever this is that's being processed. It would then be able to recognize that as either a cat or a dog and say, congratulations, you just saw a cat. All right. That's sort of how machine learning and deep learning work. Once again, pattern recognition, with deep learning just being a really, really complicated or complex version of this pattern recognition. And when I say nodes, I gave examples of 3, 4 nodes. A lot of the models today use hundreds of thousands, millions, billions, possibly into the trillions of nodes. So it's able to do this at a very, very fine resolution. And it can handle all kinds of different situations. Okay. Still, machine learning, deep learning, this is still deeply within the realm of computer scientists analyzing data. Most of us were not really utilizing AI at this point. The big step came a few years ago, more or less, when something called generative AI came along. And what this does is it can create novel products using foundation models. And what foundation models are, they're basically versions of this machine learning, deep learning for specific tasks. So an example of one of these foundation models is something called a large language model. But there's also audio models, video. There's all kinds of models, and they're being developed more and more all the time. And the difference here is that this then uses a database of this pattern recognition, but then can make new conclusions, if you will, based on it. So, for example, with a large language model, um, you, you could type in the first half of a sentence. It could then suggest the conclusion to the sentence. And you've probably seen this in email programs or possibly some of your word processing programs. That's what large language models can do. You can ask it to write something for you. Audio models can create a sound. You can ask it, create a totally new song, and it will either play or sing a new song for you. Visual models, you can ask it to create a picture. You can go in and say, I would like a picture of a cat wearing sunglasses, playing a guitar, and AI will generate that picture for you. Once again, based on all that it has learned through the machine learning, deep learning. And you can combine audio with visual to make videos and so on and so forth. And that's where all these deep fakes come and all these other types of things. As and so there's just a lot of uses of how generative AI is being used these days. Um, so even though I'm sure you've heard a lot about AI all the time, the next question is, how often do you actually use AI? And whether you realize it or not, you're probably using it all the time. Just about every time you open your phone and do something, AI may very well be involved with that. If you do an internet search and you get a list of suggested websites that to look at or check out, those are probably based on AI recommendations for you. If you see a synthesis of doing after doing an internet search, that oftentimes is AI, especially in Google. They're incorporating that more and more all the time. In the field of conservation, a big one that we see is some of these apps. So, for example, iNaturalist, Merlin Bird ID, Seek. Many of you probably have these on your phones. These all use AI, and they have been trained on thousands, probably millions of pictures of plants and animals and bird songs. Once again, using pattern recognition to figure out what a robin is versus a chickadee or whatever. And now you can go out and take a picture out in the woods, submit it through Seek or a bird song through Merlin app or whatever, and it will tell you what it is. And so that is all AI, and it's all AI driven. And this is what AI is really, really good at doing. Once again, pattern recognition. And this type of thing is fundamentally changing how a lot of naturalists are even going about their daily lives. So, for example, let's say we're walking through a forest preserve and we come upon a plant and we don't know what it is. And Marianne is busy, so she can't tell us what it is. So we have a couple of other ways to figure it out. We can go to the book, Flora of the Chicago Region. In 2017, it was based on plants of the Chicago region, an older version of the book. It's 1,392 pages long and weighs around 57 pounds. All right. I'm kidding about the 57 pounds. I looked it up on Amazon and supposedly it weighs 10.1 pounds. Okay, so it's a huge book. You don't really carry this thing into the field to ID stuff. Or you can have this app on your phone, all right, to ID the plant. And I have both. I have the book, I have the app. There are pros and cons to all of these methods, both of these methods right here. But I will tell you honestly, right now, if I have to ID a plant 99% of the time, I'm not using the book. Some other examples of how AI is being used in conservation is research. I just sort of grabbed this paper. It's about artificial intelligence and machine learning applications in forest management and biodiversity conservation. So we're seeing more and more papers like this with people using this to basically analyze data, is what's going on right here. Is that when I talk about these apps and these research, this data analysis, a lot of it is firmly embedded in deep learning. All right. A lot of academics and conservationists, they do use this type in their activities. There's an interesting hesitation and reluctance to make the jump to generative AI. I have given some talks about this before, and I will say that most of the people in the crowd were uncomfortable with generative AI, at least within their professional lives. They didn't really want to use it very much. So So although there is somewhat of an acceptance for machine learning, deep learning, generative AI, yeah, there's a lot of hesitancy still. All right. So that said, I've already talked about some conservation applications through the machine learning, deep learning. I was curious, of course, what can generative AI do? And I thought I'm going to give you an example, or I'm going to go through a couple of tests that I gave to generative AI to see how they would fare and what were the consequences. And the first test was very simplistic. And I just went to, in this case, ChatGPT, And I asked it, write an introductory paragraph for a report on Wolf Lake in Chicago and Hammond. So this was my question or prompt that I asked it. And its response, which I got, a couple seconds later, was Wolf Lake, located along the border of Chicago, Illinois, and Hammond, Indiana, is a unique and valuable natural resource that plays an important role in the environment, recreation of the surrounding communities. Known for its diverse ecosystems, the lake supports a wide range of plant and animal species while also providing opportunities for fishing, boating, and outdoor education. As both an urban and ecological landmark, Wolf Lake reflects the challenges and successes of preserving natural habitats within a heavily developed region, making it an important subject for environmental study and community planning. All right. I mean, in my opinion, this is a pretty good introductory paragraph. It does sort of depend on, what your report on that. But you could certainly use this if you were writing a report, or you could tweak it to fit whatever you wanted to do. So this is an example right here of generative AI using a large language model. I asked it to write something, it went out and it wrote that, once again, based on previous patterns that it learned. All right. And so AI is very good at this type of thing. All right. But I was more interested in this. Can it find actual solutions to real world problems? And what I mean by that, or actually the way I decided, I was going to present to AI an actual situation, an environmental situation that I have seen, and I was curious to see if AI could figure out what to do about it. I mean, could it find an environmental solution to a situation that we created? Um, and I tried this on three different platforms. Chat GPT, which is from OpenAI, Claude from Anthropic, and then Gemini, which is the Google version of it. So I tried these three. Most of the stuff I'm going to present is from Chat GPT. There are actually slight differences between the outputs from these three models, and but in general, they're very, very similar. So the situation, which is in the Chicago region, has to do with something called culverts. Um, so here, the picture, it may appear that way. I was actually doing a fish survey, and I went into this culvert, and this was looking. So I took a picture of it. And at the end of the talk, I'll show this picture again, and I'll tell you what it actually is, because I do know what it is. It walked around. Um, but to get back on track, a culvert, if you're not familiar with it, the pipe, although it could be a square or made out of concrete or some other type of structure, through which a stream flows underneath, typically a road or some other piece of infrastructure. In this case, there is a road. So this is a stream flowing through this culvert with a road, and it's at a road crossing. So it's a stream road crossing. Now, swimming around in this stream are two species of fish. One's a mottled sculpin, which is actually threatened in the state of Illinois, which is an environmentally sensitive species. Both these fish are relatively small. This is a very small stream. These are a couple inches to several inches at most. Fish, a couple of small, sensitive species, basically. Um, Now, so I was looking upstream. Behind me, from where I was taking that picture, about 50 feet, at which point the culvert split in two. Now, it's kind of hard to show depth in these photographs like this, but basically from the bottom of the culvert to the bottom of the stream, which is down here, is a distance around 2.5, 3 feet. And we a continuously flowing stream per se, but it is actually drops off into a series of waterfalls, basically. And the issue here is that small fish is going to be very difficult to impossible for fish to swim upstream at this point. Oh, be a big distance for a person to step up 2.5, 3 feet, but for a fish that's only a few inches long, they're not going to be able to make this. They may be able to be washed downstream, but they are not going to be able to go upstream. And we call this an impaired culvert. And what is going on, and there's a lot of fancy lingo associated, we call this a fragmented landscape. So the animals cannot move freely within this landscape. There's a lack of connectivity, is another way we put it. There's restricted gene flow. And kind of the take-home message is if something happens to this population of these sensitive and threatened species, they could be wiped out from that portion of the watershed because they're not connected with the downstream portion of the water. There is no opportunity from fishes elsewhere in the watershed to enter this to kind of supplant this population upstream. All right. So my question to AI was this: Can situation, and this is the prompt that I gave it. I said, propose several solutions to increase aquatic movement at a road crossing with a round culvert and 4 feet in diameter, 30 feet long, 4 inches of water, and the outlet's elevated 3 feet above the stream level. So this was my basic question. So I asked AI this, and this was the response. And I'm not going to go through this response in detail unless you want to, which is great. Fish biologists and stream biologists could talk about this forever, but that's not the point. The point is AI gave me an answer, and if I were to grade this answer, I would say, it's like 8%. It's a great answer, really, really good. Not perfect. You could tweak it, but I mean, very, very good. Um, So that's impressive in and of itself. But what's truly impressive is that if I were to have asked this question of, say, like a young professional, someone that has a background in biology and ecology, stream biology, but maybe not specific knowledge of this particular topic, if I asked someone to do the same thing, it would take days to possibly a couple weeks to turn it around and give me an answer of this quality, whereas AI did. All right. And this was absolutely stunning. I mean, it was so quick. So you get a high quality quick. The next thing I did, I asked it, can you rate these answers based on,
Oh,
friendliness? Which ones were most effective? And it was able to do that once again in a matter of seconds. I then asked it, can you give me a cost estimate for these various
that's no
methods?
problem. Next time it flashes up.
Yeah. Can you give me a cost estimate? It could do that. You can do a cost benefit analysis. I mean, the productivity was absolutely crazy about how quickly you could do all of these types of things. Once again, the answers aren't perfect, but wow. Yeah, it did really, really well. Now, the next step after doing all this and interact to get a little freaky and weird because then AI started asking me questions. For example, it said, would you like a site-specific recommendation based on additional constraints like target species? I told you earlier which species were there, the model scope and a Brooks took to tell AI what species. It's me that. I then told it, says, yes, there are model scope and Brooks stickleback there. AI went back in and actually tweaked its answer based on the ecology of these species. And it did it perfectly. I mean, because, about whatever the habitat requirements are from these types of things, it modified its answers. And that was absolutely amazing that it was able to do that. The next step, I asked for diagrams of these options to improve the situation. Now, the image generation can be a little glitchy. I kept it rather basic here, so if you look at the labels on it, a little messed up. But conceptually, this is pretty close. Um, I would change maybe these steps, making them a little bit wider, making it easier for the fish to go up and down. But in general, once again, very, very good about how it was. You could improve this, but very, very impressive. Um, Then AI asked me another question. It gave me two options here, and it asked me which one do I prefer, response one or response two. And so my first inclination right here was to dive in and sort of take a close look at the two options here. And for example, you'll see there's rocks late in here, and these help to break up the flow, creating pools. This allows move up and down stream. In this option, there's no bank, so if there's a high flow situation, you may get a lot of scouring here. Whereas over here, you have these banks, so if there's a high flow, during flooding, which is inevitable. That would handle it. So, this one looks better. But if you look at the size of the and on and on. So I was kind of looking at it back and forth. Now, then I stepped back and I thought about what's really going on here. And there's two levels to this. The first level, and the various AI companies are open about this, they are perpetually trying to train their models or algorithms to improve the response. And that's what's happening here is I'm helping train their algorithm. Sure, if this comes up again, they can do a better job answering it. Um, or at least we'll have a feeling for that type of thing. And that's all perfectly fine. But as I was sitting here thinking about it, thinking about how I was responding to it, about what AI was doing, it kind of slowly dawned on me that as I was training AI to think like me, in the background, AI was actually training me to think like it very subtly. And so there's a lot of moments where you can have a bit where it can sort of freak you out, and as you think about the consequences of these types of things, and you can have a bit of an existential crisis, which is where you see a lot of these science fiction novels and movies coming out with the horror things, where you can see where a lot of this could potentially lead once you go in there about how much freedom AI can have at times when you start interacting with it so closely that it can lead you down certain paths. And I found myself, kind of falling into that with this right here. And there are times where I've been working with AI, and I don't want to be too melodramatic, where I've actually had to kind of step away from the computer for a little bit and work in the backyard and think about what's really going on. Not just what's going on, but what's going on behind the scenes and where a lot of this could potentially lead. And I have talked with some people that are convinced that AI is not inevitable, that we should get rid of it, that it is too dangerous. But realistically, the Pandora's box of AI is open. I mean, there's no going back. People are going to use this one way or the other. And in my opinion, the only way to really get on top of this is to get ahead of it and try to figure these things out. Because if you're not using AI, somebody else is going to be. Now, I'm going to tell you one quick story, and this is a true story. Um, a few months ago, I was asked to review a manuscript by, I'm going to say, a highly regarded scientist. Professional reasons. I'm going to be a little vague here, so I'm not going to give you too many details, other than say that this did actually happen. And to take a step back, this is how many scientific manuscripts are published. Someone writes a manuscript, they want to publish it, they send it to a scientific journal. The editors at the journal will look at this, and if they just think that it's worthy to be in the journal, they potentially worthy, I should say, they will send it out to two to several reviewers. These people then read through that manuscript, write their opinions about it, send these opinions back to the editor who goes through that, and then they make a decision as to whether they will publish that article or not. There are opportunities here that if an article just has like minor problems with it, the author can fix those and then they'll publish it and that sort of thing. And this is kind of the scientific process to maintain the integrity and high standards, scientific standards of various journals. So this part's all fairly normal. And myself and other scientists, we've done lots of these types of things. Okay, so I was supposed to do this. And the first thing I did with this particular article is I went through and I gave it a quick overview. I read it, and my first impression is the manuscript was okay. All right, just okay. It wasn't great, wasn't terrible. And what I then did is I went back to the beginning and I started working through it really picky. This is how I approach all of my reviews. I always give it a quick overview read so that I kind of see what the author's trying to do, where they're coming from, where they're going. And that gives me a better idea of how to critique it in detail. So I went back to the beginning and I sort of reread this thing in detail, and some things sort of came leaped out at me. For example, one, there's an acknowledgement section that was normal in scientific papers, and it's usually, I'd like to thank so and so for providing such and such data or reading it over, or something like that. Whereas in this instance, it was more of a dedication, like you would see in many books. Subtle difference, little odd, but not overly so, I guess. I've never seen this before. So I'm just kind of, it was a little weird. And then there was a fixation in certain parts of this manuscript on sort of tangential ideas, and I couldn't quite understand why they were spending so much time on these particular topics that didn't seem central to the overall theme. But anyways, once again, a little weird, but not terrible per se. There were also some strange math errors. For example, in the text, it might make a reference to 10 species and then cite a table, and then you'd go to the table and there'd be 12 species. It was like, okay, that's kind of weird and sloppy. What's kind of what's kind of going on here? And furthermore, it was supposed to be a review of this, and certain species were not included in the paper. And that was, supposedly this was written by an expert on this group of species. Why were they not talking about this when, everybody else would certainly be talking about it? But I'll have to admit, I'm not an expert on everything, and so perhaps I didn't know something about these particular species. And there were a lot of references there to recent papers. And so I thought, well, maybe there's some research that I wasn't really up on. And I'll go look at these other references to see maybe I missed something, that was like published a few months ago or like. So I went to the literature cited section there and looked up some of these papers and was rather surprised to see that most of the references did not exist in the literature cited. They were fabricated, or in the jargon, hallucinations. I forget exactly how many papers are referenced in this particular manuscript. We'll say like 25. And out of the 25, 20 weren't real. Once again, as I said, did not exist. These are all classic characteristics of artificial intelligence writing a paper right here. And so apparently that was the case in this instance, and that AI actually wrote this paper. And the problem was a person submitted this and never said that AI was used in any capacity. They passed all this off as their own effort, not mentioning artificial intelligence. Now, it is very difficult to definitively prove that a particular manuscript was written exclusively by AI or significant parts of it by AI. In this instance, it didn't really matter. There are all kinds of other issues with the paper. The journal ended up not publishing this particular article. Um, and I talked with the editor about this and like that. But, once again, somebody did try to use AI to basically fake their work and submit a paper. I've heard some estimates that there are thousands, possibly millions of articles out there now written by AI that people don't realize were written by AI. I don't know about millions. That seems like a lot. But I suspect there could be quite a few. After all, I just saw this one. And if this person was a little bit more careful and cleaned some stuff up, I can see how some of these things could skate by. All right. So this is happening right now, and it is certainly a significant problem. I'm going to wrap up with a couple of other sort of topics right here. So, what about quantum computing? Technically, artificial intelligence and quantum computing are two separate topics. Artificial intelligence is a set of algorithms or models that computers run, whereas quantum computing is kind of a different type of computer and about how it can calculate things more quickly. You can use quantum computing to uh, run artificial intelligence algorithms, but it is it's the computer that's doing it. All right. So these are two separate topics. But with the increased power of quantum computing and versus traditional computers and the increased complexity of artificial intelligence, we're on the cusp of some major breakthroughs and basically a computing renaissance as we try to figure out these things. And these models get bigger and bigger and more complicated and are able to handle even more difficult situations. And the computers are even faster. We're getting this information even more quickly. So it's in the next few years, we could be blown away by some of the capabilities here. Now, this particular rendering, this is the quantum computing campus that is being proposed for the south side of Chicago. That's Lake Michigan in the background. This is an old U.S. Steel site. There's a bit of controversy about this in its relation to the neighborhood. Totally separate topic. But anyways, this may or may not be coming to Chicago. There are plans, at least for something like this coming to Chicago. Another question that's coming up in regards to artificial intelligence are these data centers that are doing all of this computing, and what are the environmental impacts of these? And I'm getting more and more questions about this all the time. Um, Most of the concerns have to do with energy usage and that they take a lot of power to run all these computers to do all of this type of stuff. So, and where is this energy coming from? And is what is the output of this energy? And are there perhaps climate change impacts because of this energy? That's kind of the focus on a lot of this. There could be other potential environmental impacts on these centers, similar to any large construction activity as well. Um, at this time, I'm having trouble answering these because there are certainly a lot of ideas out there. There's a lot of opinions out there. It's a little harder to get definitive facts or evidence on a lot of these things. Kind of difficult to make judgments on that, but this is certainly something that we need to look at. And I suspect a lot of agencies are starting to do that. And the next time I'm in spring, going to start asking some questions from the folks down there about how are they dealing with this and are they hearing about it as well. Excuse me. So, kind of the take-home message is this is a hot topic, but it is very exactly how to move forward with this particular topic at this time. But it is something that we need, right? And that's all related to artificial intelligence as well. So kind of circling back around, uh, excuse me, what is artificial intelligence and conservation? And as you can see, there's a lot of different types of roles from data analysis, identification to actually problem solving. People are mixed about how to move forward with this. I see a huge amount of potential about how to move forward with a good that can be done with this. You do need to think about how to move forward with this, what the proper questions are, how to approach it, and all that sort of thing. Excuse me. But I think there's a huge AI and conservation. And typically, conservationists, when it comes to tech, tend to lag behind a lot of others, particularly business and such. And I think that we need to perhaps fix this and try to get on top of that. A lot of good can come from this. But we do need to be smart about it. And I think the best way to do this is to get ahead of it. And even though a lot of my examples were related to water, you can apply this to prairies. I think there's a lot of potential with prairies in Illinois, and that AI could but solve a lot of the issues associated with prairie rehabilitation and the long-term success of prairies. So I think there's a lot of opportunity. And so finally, in conclusion, the covert creature, it was a raccoon. So if you guessed raccoon, you got that right. Um, I included on if you want to get in touch with me and some of my social media contacts. I have to be honest and say I have, so you can try contacting me through there or whatever, but I don't really look at that one. But I do all the other ones. So sorry, excuse me. So with that, let's see if I can stop. And I'm happy to take questions. I don't actually know what time it is. There we go. Yeah. So I'm happy to take questions if anyone has any questions.
Okay, I'll start. Hi, Phil. This is Mary Ann. Um, the fact that there are no, the references were inaccurate on that probably AI generated article, that I don't know how AI could be trained not to find real references. I mean, how does that even that would be the easiest thing for AI to do? Because it's just, compiling the sources it's been using to generate the report or paper.
No, I agree. I don't understand why, but I think also it's been pointed out as a classic system. So I suspect that a lot of the computer programmers are trying to rectify that and try to fix that particular situation. I don't know why I went into that. I did an interesting search earlier today, and this varies by model and model. And one of them included citate was pretty clear about website and citations and that sort of thing. but it was also pretty clear that it was copying verbatim from these various websites.
Mm.
So it was like Wikipedia, and I looked at Wikipedia and it was like, oh yeah, you copy and pasted that from Wikipedia. And then it'd say, yes, Wikipedia. So I'm like, okay, that's great. But once you start getting in, you start doing, like writing the paper. Yeah, I don't know why it gets so confused, but it really does.
Mm.
And the weird thing was, a lot of these references, if you're not familiar a certain way, it's
Yeah.
like author's name, year, title, journal, and then all this
Yes.
work. It was
Yes.
formatted perfectly. But it made up all the authors and the titles and the journals. I mean, everything else was sort of
Crazy.
made up, but it was close enough so that nobody really realized it until they looked at it in detail. So it was like, oh yeah, such and such, revision of such with authors that have actually published other papers. It's very weird.
It's
And
messing with you. It's just messing.
well, that could be. And they do call these hallucinations. Now, another interesting thing about AI that I've seen, various tracks of thought, and it keeps thinking down paths. I don't know how else to say that. And it is really hard to break it out of that train of thought sometimes. You want it to do.
For
And
internet connection.
there are ways to do this. You can kind of like stop your analysis right there and then start it.
Anything about that?
That sort of thing. You do have that option. Like sometimes they call them projects or something. Every model's there's so many do it slightly differently. But I have noticed that it can get really fixated on certain facts that
Mm.
once again, sometimes it makes up these facts. I don't know where it gets this information, and it just you can't get it to break out of that train of thought.
And
And so it's
also
a little weird.
very fawning towards you, it's like it wants to be not crit it wants you to love it, so give you what you want is some of the experiences I've seen and had. I haven't done much with this, but
Yeah.
um you there, yeah, it's very straight. And I have to go shortly to catch a train, but I just want to say excellent, just sort of set up and just talking about a little bit of a conservation example and then the paper thing. Very good, Phil. Really
Yeah,
good.
thank you, Dave. Good. I should another thing I should add in general. If I were to give this talk tomorrow, it could be a totally different talk. This field is so fast. It's crazy how fast this is moving and what everything that's happening right now. So, stay tuned. I mean, yeah, it's weird. It's crazy. Oh, and this brings up, see you, Dave. I have one other interesting story, and this isn't me, but this is my wife and son were in the car driving on a car ride, and they got into a discussion or a disagreement over something. And so my wife pulled up AI to answer the question. I don't even remember what the question is. I wasn't there. I'm hearing this secondhand. So that it answered the question, and AI gave their answer to it, and she did the phone down, and they kept driving, and they kept talking about it, my wife and the son, and then like 5 minutes later, they were so talking. AI just out of the blue said, "Wow, that's an excellent point you just made there with that." So AI was actually listening for several minutes as this conversation continued and then jumped back into the conversation to add a point to it. All right, because my wife did not think to turn off the AI app. So that was like, oh, that's interesting. I mean, even when you don't think you're participating, AI is still participating in this particular thing. Now, whether it was accurate or not, I don't know. I can't remember. But anyway, so that's just another sort of interesting story. So anyway, okay. So Terry, you have your hands up. You have a comment or question?
Well, I mean, I think we need to, I think your presentation was great because it really it shows you how this thing builds itself out. You adjusted things and got to where you wanted to be and how you're making it smarter.
Hmm.
So I think that's a big thing. We're making this thing smarter too. But the other side of this thing is I think as a public, we need to start speaking out about regulations. Uh, so this thing doesn't get so out of control that it's going crazy because it's already seems like it's kind of hinted that way. And a good example is we need all this power. Uh, what about the crypto boys? Look at the power they're eating up with AI. There should be restrictions on them instead of just a way to go and milk the system. And so that's an example. example that we need to think about, we need to really get serious about, is the green space around these. Okay. And we've been having some discussions with the people in Hammond about the state line generating, because that's actually lake bed property. Trying to emphasize that. And, we're trying to do some convincing that that whole outer perimeter should be put back to more of a natural nature perimeter around the data center. So, and I and referred to the current situation over there as data center ghetto, because it looks horrible there to what the responsibility and the promises they've made in the past, and ComEd is just squatting over there, and they don't need to be there anymore. And so you got all those ugly structures over there. And so, I mean, those are things that I think we got to, come together as a community, start making some demands on corporations. And your presentation really lays it out how this thing is coming after us, whether we like it. Great job.
Yeah, thank you, Terry. It is very much a wild west in many respects right now about how this is moving forward. People are sort of um, I, I don't know the details, but the European Union is enforcing or going to enforce some type of regulation so that if you go through AI, it will trace where it got its information from. And I think this is try to make sure there's no and some type of verification. I don't know the details, but they're trying to impose some type of legislation, and they're going to, I guess, but I don't to try to rein in some of these that it's stealing their data and all that sort of stuff too, which may or may not be legitimate concerns, depending on the situation. In some ways, sort of is similar to what we saw with wind farms and solar farms ago, where these things all of a sudden started popping up all over the place. And regulatory agencies didn't know exactly what to do with them at the time. But now they've sort of figured that out. You may or may not agree with how different, agencies are doing that and how different states are doing that. But it took them a while to get on top of that. And I'm not seeing anyone that's on top of data center regulation right now. Is just they're just going in and doing things. And so, yeah, we'll see. And that's why I'm, like I said, I think in the next month I'm going to be in Springfield at least twice, asking questions face to face with certain DNR folks. I'm kind of curious if they've seen anything. What do they know? Do they have plans about that? So this is, talk to me again in a month or two. Maybe we'll know more about what's happening. I don't really know. So, yeah. Let's see here. I don't know if there's chat questions or.
Yeah, I think Madeline has a question in
Oh, yeah.
chat.
Hi, that was a great presentation, and I'm so kind of freaked out by AI, and I know I use it all the time without realizing it. So I was hoping for a presentation like yours to help me understand it a little bit better, sort of in a comfort zone. So thank you so much. And I had a similar question to Natalie, I think has a question also in the chat, sort of how specifically can we use it? Maybe you gave the, example in the presentation early on, but then you mentioned maybe prairie restoration and that AI, has capacity to help us solve a lot of problems in terms of prairie restoration, for example. How you might, use it there?
So, yes. And then, but I'll step back a sec and I'll say, and I didn't really make this clear. When you're working with
Mm.
AI, the prompt or question that you ask it really matters. And sometimes it can take a while to come up with an appropriate question as a starting point and how you want it to go. So, for example, I've talked to a lot of AI. They ask it, they say there's no such thing as stupid questions. They'll ask AI a stupid question, they get a stupid answer, and they're like, AI is worthless. I'm not going to use it. It's a complete waste of time. When actually it was on the person for not asking a question that AI can really work with. So if you ask good questions, you can possibly get good answers. That's it. And I've had trouble. Sometimes it can take me a while to come up with what I think is an appropriate approach or series of questions to get at what I want. Now, the reason partially because I forgot to say it in the talk, I missed that part. But the other part is with prairies. So I'm an aquatics person. If you don't know that, I don't really think much about prairies. But I'm on some state boards, endangered species. And so for the past couple of years, I've been sitting in or listening to and evaluating a lot of endangered species in prairies and thinking about prairies and thinking about how prairies function, all that stuff throughout the entire state of Illinois. And while I'm thinking about all these things, it really opened my eyes to how prairies may possibly function, in that people seem to think that prairies are static and that a prairie is a prairie. And then going back and I'm looking at it, and I'm like, no, these things are really in flux. They're changing all the time. But they certainly need to do that. And I think you really need that type of thing to maintain the biodiversity, both the plant and animals within a prairie. But when you think about that, I quickly got overwhelmed. But now that I'm thinking about it, I'm like, I could figure this out and model some of these things and maybe give some insights on better ways to manage prairies, particularly in regards to endangered species. Um, and so the problem is I haven't had enough time to think through that, but I think that kind of approach really work with prairies and other systems. Key there is to come up with not one question. So for example, a lot of people are like AI to solve climate change. Well, it can't. That's too big. It's not going to do that. It can't work. But I think if you can come up with tractable or tractable questions and series of questions that maybe based on previous answers you can modify your subsequent ones, I think we can gain insights like that. Now, fire's an easy one. You could easily ask AI to write a fire management plan for a prairie, and I bet it could do that in a heartbeat. And you could go in and tweak it, and you'd have a great plan. But maybe a little bit more, that type of thing. So this is something I think there's a lot of opportunity there. The problem is I can't. I'm still thinking about it. I don't have the right question. I don't know if that really helps you or not, but that's kind of my approach to this, and why
Yeah.
I think prairies could really benefit because we have so many in Illinois.
Well, I think that aspect, yes, that was super helpful and just helping me to understand how the thought process around all of this is really helpful. And the aspect of change and kind of dealing with that question is to understanding AI's capacity. Thank you.
Let me know. I'm curious. I mean, this is all feedback here. I mean, like I said, this is wide open. We're all trying to figure this out together.
For sure.
Let's see. DERS, can you add ethical? Yeah, you can do whatever you want. Sure. You could add ethical statements like don't include fiction. Do that. I haven't actually tried. I don't know if it would do it or not. Um, you different ways, but will it listen to you? Like I said, sometimes it's very good at listening to you, and sometimes it just gets a mind of its own and doesn't do so. Around with AI with a lot of other types of things. Um, for example, I was having some car trouble with that, and I used AI. My approach to these things is I don't completely believe AI unless I kind of know the answer already. All right, because that's just sort of me. But now, don't think too poorly of me. I kind of think the same way with people too. Everyone's like, "How can you trust AI? It might, lead you astray." I'm like, "Well, guess what? People have done that to me too." Okay, sorry to say that, but that has certainly happened. Something really important. I need verification. I need backup. Give me the especially on something that's a really important question, environmental question. So I was having trouble with the car. I asked AI to fix it, and what it figured it out. It gave me a number of them with the most likely one, and it was correct. And I had a plumbing issue at AI. I said, "What is the potential problems here?" And it nailed that one too. something. I was making a homemade hot sauce recipe. All right. I liked kind of doing these things and I was modifying these types of things and they kept molding, which is sort of an artifact. This total failure. AI could not figure out how to fix my hot sauce recipes like that. I did finally figure it out. So I'm making all kinds of hot sauces and it's all fine. But the thing is, AI could not figure out if I was just asking bad questions. So you do the kind of the mess. Yeah, it can work great. It can also fail miserably. All right. And I've seen it do both. Um, this one, how can we protect human jobs in the time of AI? Thanks again. This is coming from Blake. Um, that's certainly consequences of that right now. My son's trying to figure out what his career is going to be. He's in high school and he's already rethinking what he's going to do based on AI. He's like, this is what I would like to do, but will that job be there 4 or 5 years from now? And it may not. Or it may be a very different type of job. Now, there are certain types of jobs that are disappearing more quickly than others. Interestingly, computer programmers are disappearing. They're not really needed anymore. I'm saying that's a broad generalization. Um, a lot of other jobs that kind of handle data manipulation can also be disappearing as well. Analyzing certain things like customer service can be taken over by AI very easily. These types of things, you still need a little bit of AI oversight. The jobs that are most stable, and I don't know, they say, can you protect those jobs? Probably not, to be honest. A lot of these, it's going to be different. Now, that said, um, in the field of conservation, we still need the boots on the ground. AI is not going out there picking native seeds and spreading seeds. All right. And we don't have robots doing that yet either, or drones. Okay. And it's going to be a while. AI is not pulling nets through the water and telling us what fish live in it. So there are certain types of things that AI is not doing, and it'll be a while before they can do anything along those particular lines, those more manual jobs. There are certain jobs where you need oversight of the I would argue. It's a thing. Data analysis of a particular situation, but before moving forward, you need some type of particular thing. I don't see AI getting into regulatory frameworks anytime in the near future because there's just too much risk involved with that at this time. It can be a tool for leading up to potential regulatory decisions, but actually, I'm going to guess is going to be a little slow for adoption. That I would hope and I would expect. So there are certain types of things, but you need to think about it actually, especially if you're a young professional, about where this is going to lead and what are the consequences of a lot of these types of things. Um, for example, I gave that talk, the example about the impaired culvert. I mean, at one time I could have asked that person busy for several days. I don't need an intern to do that anymore, to be blunt. I mean, there could be other tasks, but that type of thing is going to be disappearing, or at least I still need interns to pull nets through the water to tell me what fish are present, or at least show me the fish so that I can tell them what fish are present, that type of thing. So I'm not saying that there are certain tasks like that I just don't see in the near future. So do I know where it's going to lead? No, I'm not going to pretend that I know where it's going to lead because it changes, just so fast. Like I said, let's see here. Blake had another one. Can AI and humanity coexist together, help endanger species for future generations? So coexist together. Um, I people have opinions about this, and they've had, read these. The people that have thought about this the most, and this is a little dorky, are the science fiction movie people. And I'm not going to say that they're completely correct. The theatrics of horror and dystopian and all these types of things, because that's going to sell novels and movies. But you will see that thought about it for a very long time. So I wouldn't believe everything you read in a sci-fi novel, but you can take certain pieces of that because, as I said, there has been a certain amount of thought and they spend more time thinking about it, at least in a certain way. Um, a lot of those novels say, no, they don't really seem, it's all horror. No, they can't exist, this and back and forth. Um, it kind of depends. I think people need to get ahead of this. Don't let AI dictate this. Don't let it be a runaway train. Try to get ahead of it and deal with it that way is probably the best advice that I can really give for that particular answer. Terry has another comment.
Yeah, I think a big thing we're going to have to push is the fact that we're going to have to demand the proper landscape.
Yeah, yeah. It's kind of how we're going to approach this. I think we need to figure that out. And I don't think the conservation community has really thought about this in as much detail as I would like to say. Once again, I did give this a similar version of this talk some months ago, and people did not like AI. They were, I would almost say, anti-AI. About half the audience was not on board at one level or another. I would say the audience was more or less ambivalent, and only like 5 to 10% were really in favor of using AI that much. That said, as I already kind of mentioned, there's AI is such a huge topic. There's different levels of it. You can origins of AI to analyze your data, and it's really not much different than a stats program on your computer. All right. So it analyzes your daily data. This group's significantly different and not significantly different from anyone has a problem with using AI for doing that, and AI could do a very good job at some of those types of things. It's when you get to the generative stuff where it starts coming up with ideas, that's where people tend to get a bit more reluctant about it. And I totally understand that, which is kind of why I wanted to jump into that realm because I was really curious about what would happen there. And I went in semi-skeptical when I started. I think there's a huge potential. I think that good with this type of thing, but I wasn't being melodramatic. It did freak me out at times about how it was interacting and doing these things, especially when it starts doing something that you don't anticipate coming up. And you're like, wow, I didn't even think of that already. Now, that said, I would also rate the answers of my interactions, the quality of my interactions, roughly equivalent to working with an advanced undergraduate. That's kind of the level of out of AI. And interestingly, I was watching a YouTube video, and it was one of the AI leaders, also said about an advanced college undergraduate, maybe about around there. That's about the thinking capability, if you will, of AI at this time. Okay, how far beyond that is it going to advance? About that, is AI going to get smarter than people? There's a lot of speculation about that. Another thing that I guess I could have talked about this a lot longer. What do you even mean by intelligence? And this is a huge field in or a sub field of psychology about, what is intelligence? What is creativity? This may sound simple, but it's actually kind of a very complex question about how you even assess this and what do you even mean by it? And can computers even really do that? A lot of people say, okay, pattern recognition and then drawing conclusions from that, that's not really intelligence. And yet, that's a lot of what people do. They go to school, they learn these type of things. You pick up this pattern recognition and then that. That. So if you define intelligence that way, that's what people do. So, it's a mix. And there's a lot. All of us have a lot to learn about this. That's kind of my opinion.
Sorry, my
Oh, yeah, no
discussion.
worries. So what was your question or comment?
Well, I mean, I think we need to be proactive Especially and I think Blake brought it up. How do we coexist, I guess, with all these things going on? And, state line generating is nature back to that area. The old South Works there in Chicago. These data centers and quantum leaps and all that. They're not concerned about the ecology around that needs to be part of the guidelines of implementing data centers, that they have to have this green space that's provided in nature, not just grass, but it's going to have tree canopies, it's going to have native plants, you're going to have some rain gardens and things like this, so that these things can actually coexist together a little bit, and we also don't destroy what we've already destroyed and make it worse. So that's my main point there. So it's just it's a and the cities aren't really taking it up like they should either, as far as looking at the green space around these facilities that want to be built. There should be a perimeter all the way around, especially the like state line generating and Southworks. That's lakefront property. The public needs to have access to that lakefront. So there should be a parameter there to where you have the green space for the public to enjoy that and have some happiness, taking away all our happiness. So that's my point.
Yeah, no, and I agree. There's a policy angle to all of this that I'm not sure anyone has really delved into too much. People, maybe there's people like what we're doing right now, where we're just sort of talking about it, but are we moving it forward? And so I wasn't kidding. Next time I'm in Springfield, which in a couple weeks, when I don't, this month's already flying by. I know it's like the 6th of January, and I feel like the month's over already. I'm gonna ask. I'm because I need to get to this because I'm getting questions on many different levels about these data centers and their impacts. And I'm getting them from the press. I'm getting them from, concerned citizens. I'm getting them from everybody. And I'm curious about, what is the policy? How are people moving forward with this? Is there any way to move forward with these types of things? But I also, like I said, mentioned earlier, it's hard to know what the facts are or the evidence associated with what everybody says is it's a huge, energy. What does that mean? We need to get more information about this. At least I feel like I don't have all the facts right now to be able to answer a lot of these questions in informative way. Where if I'm in a position to make a judgment on these, I would be able to make a thoughtful decision based on that. And you do need to do that. So, because, once you get into the policy realm, you're going to have to be able to defend your decisions if you're making regulations based on this. So you need that evidence. You can't just say, "Oh, you can't do that. You're using too much energy." You have to be able to back that up because if you get dragged into a court, you can't just say that. You got to have something. Entirely sure how far along federal agencies on that. Well, the federal level's whatever at this point. I'll skip that whole thing. But different states are going to approach this. So, and that's going to matter. Illinois and Indiana have a history of approaching these types of questions sometimes with other states. So,
I guess you can say the energy thing is beyond the states even. It's a matter, it's like in Indiana, it's MISO and NIPSCO. Uh, Data centers that want to come into town everywhere, they can't supply the energy is the big thing, and I think that's part of because that's a different grid. That's the PJM over there, So all these energy is a big factor in this whole thing. The other issue is the water, because now they're coming up with different the data center that's currently there at State Line Generating uses Lake Michigan water to cool off everything, and these other ones are coming in trying to come in with some kind of closed system where they use air cool and gels and all kinds of stuff. So they own data center technology. It's changing, So you're right. They've thrown this mess at what direction to go.
Yeah. So water regulation, there should be frameworks in place to handle that. I would guess. Here again, I don't know Indiana as well as Illinois, but if you treat that as you would like a power plant or any other situation, you could easily invoke those types of regulations and then follow that route, however it is, or any other type of industry with that. The energy one, as you say, that one's hard because of the grids. And I don't understand the grids. I'll tell you right now, that's a big complex problem that with the power coming from all these different places and routed this way and that's all crazy. So I don't even know how you would approach that. But yeah, here again, it's something we need.
I just put an article in the chat about water and water concerns related to specifically to the PsiQuantum um, quantum computing site at on the U.S. Steel site on Southworks. So I found I don't know, it might be of interest, especially related to water regulations. And one of the things that is kind of mentioned on the PsiQuantum from their perspective is like, oh, well, we've never really, like, we have a plan for this, we have a plan for the water, and then that kind of changes. But it's also a notion that, like, well, we've never really done this before, of still figuring out how what the water usage might be or might look like. And it's I think causing on the one hand, it's sort of a different, two sides of the coin. Oh, we know what we're doing and this won't hurt any water because it'll be a closed system, but it needs to be near the water. So what is that? Um, there's an unknown that they're expressing. So that's something just in terms of fish and regulations. And yeah, you would think, well, aren't how can there be so many questions around this? Shouldn't this just be a basic, regulatory scenario? And it may be ultimately, but it may not be. So something, obviously our governor is very excited about and there, of course. But then there are also, clear concerns from especially specifically around that project. So maybe of interest in what in
Yeah, no, I mean, yeah, like I said, I can see that there's a framework there for regulating the water. I can see how that should work, and I don't. And it should, whether it's a power plant or a factory or drinking water or all these things have come up, and there are permitting issues associated with all of these things. So there's certainly a framework. And
yeah.
if there's an endangered species nearby, then there's a whole nother layer to that framework and review and these things. And I know there is because I've seen all these things and I've had to review a lot of these types. Um, for some of this other stuff, I I don't know. I'll be honest. I don't know how to approach a lot of these things. The energy is the big one. I don't know how you, I don't know. I don't know how to approach that. I need to look into it some more. It's coming up again and again and again. And it's not going to go away. We're just going to have more of it. So,
Are you getting tired, Phil?
oh, I could go all night. How about you? No, I don't want to.
Uh, this is so interesting. I'm learning so much. Um, um, all I know is I got a lot more to learn. I think, um, but yeah, I just found this to be fascinating. Um, but I think we're running out of questions. Am I correct? So Valerie and I would like to thank you for your talk today, and Phil. And I want to see you next month when the speaker for Calumet Revisited will be Dr. Larry McClellan. And we seem to have him every February of the of the years. For those who have been following us for the last 10 years or however long, February is McClellan month. So thank everybody for coming, and we'll see you next week. Take care.
Well, thanks for seeing
Good
everyone.
night.
Thanks, everyone.